Okay, so I am Chris Wilson. I work for Google. I'm a developer advocate on our Chrome web developer relations team. And I have been working on the web platform for just over 24 years now. Since 1993, I co-authored the Windows version of NCSA Mosaic. So that's like how long ago I started this. And I actually worked on every version of IE from IE 2.0 through IE 9.0. Yes, it was all my fault. I'll just get that out of the way up front. Most people blame me anyways, so I figured. Mostly the Edge team, by the way. And I did write the first mass market implementation of CSS, which is, at least I should get credit for that. It wasn't the best. It wasn't the best, but at least I deserve a little bit of applause. But we're done now, so we can move on. So I've been at Google for nearly 7 years, and I have to say, one of the coolest things to me is that the web platform continues to amaze me. Like, I've been doing this for a super long time, and we've come an incredibly, incredibly long way. When I started working on the web platform, it was a hypertext platform. I mean, hyperlinks and text, that was pretty much it. Like, you didn't get this kind of experience. You didn't get apps that were indistinguishable today from a native mobile application, for example. I've been sitting in the audience today, as I usually do before my own talk, and stressing about how great the speakers are. And watching, Rachel showing the beauty of web animations, and Ruth talking about audio and MIDI, a subject very near and dear to my heart. Ada Rose showing the future of VR. And by the way, who remembers VRML? Wow, I really am old. Okay. And then Patrick covering progressive web apps, which is kind of what I've spent the last 2 years of my professional life doing. And it kind of begs the question, like, what else is there to talk about? What else is really important at this point? I mean, hardcore CSS is tomorrow, so like the visual rendering stuff. But I want to say the most important thing, the whole point of progressive web apps to me, much like Ajax before it, it was about reducing friction, right? Making it easier for users to do things, making it easier and easier to access experiences. And with instant loading and installability with progressive web apps, we're at this really good place, but there's still friction to be found across the platform, across experiences built on the web. And we really want to develop these really good relationships with our users. And in order to do that, we need to remove any possible friction that they might encounter. And there's two critical areas for sustainability that we really need to address. And the first one of these is just getting users to come back, getting users to re-engage with their site, getting them to sign up and then sign back in when they come back. And then, of course, everyone's favorite is getting users to give you money. Now, like, I tend to be a fairly hardcore liberal, I guess. And sometimes I feel badly about working for large companies that pay me well. But at the same time, most services are for profit, right? We shouldn't feel bad about getting paid for things that are valuable, trading things for things of value. And these two problems are really what this talk is about. This is why I'm actually combining them together, because I think they're both about removing the next set of friction for users. So some best practices to manage sign-in, and Web Payments API and how that helps you get paid. So to start out, how many of you work on sites or apps that have user logins, that use them as a consistent thing? Okay, so more than half, easily. How many of you are happy with your current sign-up and sign-in flow and how many users are logged in on a... I don't think there's a single hand up. That's I've never asked this question before in front of an audience, and I'm kind of amazed. But I'm not surprised, or not overly surprised, I guess. I'm a little surprised there was nobody who was like, oh yeah, I think it's great. But let's start with the bane of everyone's existence, passwords. Now, passwords suck for many reasons. The first one, of course, is even though every user in existence has some idea of the best practices for passwords. They always use short and simple passwords. And I'm saying this as a general statement. Of course, there's some guy in the audience who's thinking, no, my password is 23 characters long and it's random. And that's true, but can you guess the most, and if you've seen one of our Google I/O talks, you can't answer, can you guess the most frequently used password for 3 years running now? Good guess. I think I heard it out there. It is 123456. Now this is barely better. It's 1 digit better than the kind of password an idiot would use on their luggage. I'm sure some of you know the reference. Thank you. Now we were secretly hoping that this year it would at least go to 1, 2, 3, 4, 5, 6, 7, but unfortunately it came up a little short. And yes, password is consistently in the top 10 as choices of passwords. So that's pretty bad, but what makes this even worse is users consistently reuse these short and simple passwords across sites. So not only do they have a weak password, but they use it in multiple places. So if one of them gets owned, they're kind of screwed. And of course, most users don't enable second factor authentication, which is a powerful helper to prevent password reuse. How many of you have accounts with two-factor authentication and have it turned on? So pretty much most of this room. How many of you have accounts with that you know support two-factor authentication and don't have it turned on? Okay, so still a good third of the room. And I'd point out, this is a really technical crowd. Like, you're the sort of people who would understand what two-factor authentication does, why it's a good idea, and turn it on. So our end goal really needs to be identity needs to be a first-class citizen. Like the idea, the data point that no one in this room is happy with their login flow and getting users to sign in kind of says something. And what we really want is we want the browser to be responsible for managing your identity. Not really the browser so much as just the user agent. Whatever's accessing web services, like we used this term user agent to define what we commonly think of as browsers and in other software on purpose in the early days of the web because it is the user's agent. It works on their behalf. And for things like passwords, identity providers, second factor authentications, biometric re-authentication, that kind of stuff, the browser should just take care of this identity management. Simplify the process down to just getting the user to say, oh yeah, I want to do that. But we need sites and apps to be able to participate in that too. They need to be able to say, okay, now I want to get the user to sign in. And we really want returning users to be signed in as automatically as possible without typing. So I'm going to talk about the Credential Management API and how that helps, but I also want to talk about how to start small, how to optimize your current situation. And one of the ways, by the way, is we also want federated login to be supported by automatic login, where Google, Facebook, Twitter, or whatever, someone else can vouch for your identity. And the main reason for this is because these types of logins are typically the ones where users will turn on two-factor authentication. Like, I know I have two-factor authentication turned on for both my corporate and my personal Google accounts. I have it turned on for my bank. I'm not going to turn it on for like my insurance provider, right? Like, I just don't want another set of text messages coming in or another dongle or whatever. So people are more comfortable doing second factor authentication on something, on a federated login, on something they use for more than just one place. But right now, what we really want to do, we know passwords aren't going to go away anytime soon, so we want to make it easier. And number one thing for you to do on websites and apps is help password managers do their job. Like, every browser has a password manager. There's tons of external options as well. We should make their job for users easier. Chrome, for example, we consistently fill about 9 billion form fields and passwords every month for our users. So this is huge. Like, this is a huge number of of passwords and everything that we're filling out, but it doesn't always work perfectly. And the reasons why it doesn't work perfectly, the top reasons why all password managers kind of struggle sometimes, is really three main things. Broken markup, improper annotations, like we don't semantically know what a login field is. Unnoticeable form submissions, like we don't know if you successfully logged in or not. And mixed security models, which are always kind of horrible. So markup and annotations, I actually was having a conversation last night over dinner about semantics and how important they were. And I was going through my slide deck again this morning, and I was thinking, this is a perfect time to point out the semantics of this. The semantics of, hey, this is a form, and that form contains these fields, and this is the one that is the user log, like the functionally the user identifier. Like these things are important, and declaring semantics still makes a tremendous difference. So figuring out the meaning of fields can be kind of difficult for password managers if you don't say, hey, this is, for autocomplete purposes, this is the username, because you might have a user identifier, a name, and a phone number field. Which one identifies the user to you, like to you as a site? Is it their phone number because you're reliant on their phone number, or is it their email address? You don't know. Now the second thing is that password managers typically are built on a principle of only offer to save the password when you know that the user logged in successfully. Now to check that, we have this kind of simple heuristic, and I was kind of surprised the first time I learned it. If the login fails, typically the next page contains another login form. So, because you'll get a second try. Like it'll say, oops, sorry, your password didn't work. Do you want to try again? And it'll have login and password. If there isn't another login form on the next navigate, it presumes you logged in successfully. Now this sounds a little simplistic and crazy, but this is the way it works. This is simple for conventional form submissions, but if you use XML HTTP request or the fetch API, and you don't have a navigate to hang this off of, we don't even know how to check if the login form's gone. Like, when do we check that? So if you do two things, remove the login fields, remove your login form, and use history push state to just say, hey, there is effectively a navigation here, and that will trigger the heuristic for password managers. And then finally, HTTPS, and I want to make a super strong case up front, just move to HTTPS. Who is building stuff that's purely on HTTPS sites today? So that's awesome, because it's a good third to half the room. And if I asked that same question 2 years ago, it would have been like maybe a tenth of the room. So I love that we're moving in the right direction. HTTP pages are fundamentally insecure, and you can inject JavaScript to steal credentials, modify the target URLs, all kinds of other nastiness. We'll also frequently find websites that have sign-in forms on their insecure page, and the sign up is on a secure page, which is goofy because we can't migrate the stuff from the secure page to the insecure page. So the user gets a bad experience and they have to keep retyping. Some devs think, hey, I'll just embed an iframe with the HTTPS page, but this isn't any different. Like, you could easily hack that on the wrapper page, put in a spoof page, and get the user to type their credentials in. So, again, bad idea. Just use HTTPS is the answer here. Now, I want to briefly mention one other common problem, and one thing that we're doing to make password managers better for users overall, which is phishing, like trying to trick the user into entering their logins and passwords into malicious sites. So well-designed phishing pages tend to trick nearly half of targeted users. There aren't very many of these, to be honest. Like, well-designed is a pretty high bar. But the concerning bit is even the laziest phishing pages, like the ones that really don't try at all, they misspell stuff, wrong logos, just have a username and password field, to enter your bank information. These still trick like 3% of users. Now, you can just say, well, those 3% of users are kind of maybe not the users I want, but they're still your users. And if you have a large user base, that's probably a lot of people, and they're going to be really unhappy. So the security team in Chrome and other people looked at this a while ago and said, hey, you know what? A user who doesn't know their password, it makes it kind of hard for them to be phished. The less a user is responsible for typing in their password, kind of the better off they're going to be. And we're not just saving time, but we're actually giving the user a better experience if we automatically sign them in, and we're making them more secure. So as we've improved the reliability of password managers, people start getting used to the idea of, hey, maybe you don't have to come up with and memorize and type in your password all the time. So we've actually been running an experiment in Chrome for quite some time. You've had to turn it on in settings, but to basically offer to generate random passwords for people. And we've been working on with this as an experiment for a while. We want people to be really comfortable with it. We're likely to be launching this pretty soon. And once we get all the edge cases addressed, and once we ensure, of course, that users can get back to their password, because that's usually a challenge too. Okay, so this is what you can do with stuff that works today, just tweaking the things that are there today. But to really optimize the sign-in experience, like I said, this is kind of a partnership between your site and app and the password manager. The site's got to participate a little bit too. So we have this API, the Credential Management API, open web standard, to enable a seamless sign-in experience. It's currently, I think, only implemented in Chrome and Opera. But it has three main benefits. And basically, you can get a one-tap sign-in by showing an account chooser dialog. So you can say, hey, I want you to sign in, and the password manager can say, oh, cool, I have these accounts for this domain. And this way, users can sign in without having to type in all their account information. And again, I haven't really gone into this in great detail, but remember, over half of web browsing today is occurring on mobile devices. Like, let's be super clear. This has the worst keyboard imaginable for typing a lot of stuff in it. At least, maybe I'm not imagining hard enough, but I have a horrible time trying to type in information in it. And secondly, the Credential Management API can actually remember federated accounts like Google or Facebook, and users can get a consistent experience for selecting those. You can see here, and actually in the last animation too, it's storing a Google account along with a password account, password-based account. And then finally, the Credential Management API enables automatic sign-in. Websites with short session durations, like my bank, for example, it doesn't want to leave a login session open, but it also knows, like my password manager knows that it's me, it has my information, and it could work together and say, oh yeah, when I go to my site, let's go ahead and log you in, and do that automatically. Sorry, I just popped the battery out of my clicker again. This is why I need a new clicker. Now, we've actually been talking about this for a while. We introduced about a year ago a couple of websites that were starting to use the API. They mostly implemented the feature for their desktop websites. But we're seeing more and more of these come to progressive web apps on mobile. So for example, Flipkart actually about a month ago launched its Credential Manager API-based experience. Super easy sign-in, seeing lots of success with that. WeGo, who's a travel startup in Singapore, they also launched an implementation recently. They have a really nice sign-in. And one that I definitely wanted to talk a little bit more about was AliExpress. So AliExpress is in China, huge e-commerce vendor, and they launched their integration a while ago, and they actually came up with some engagement numbers from this. And they realized that they had achieved 41% higher sign-in rate just using Credential Manager to get users signed back in automatically. And they decreased their sign-in failure rate by 85%. Like the people who couldn't remember their password or just gave up after one try, that went away by 85%. Like, this is kind of amazing. So I want to briefly dig into how this works, along with some upcoming changes. To get a credential, you basically just call navigator.credentials.get, and you can give it different parameters. You can tell it, hey, I want to support password credentials. I want to support federated credentials. You can specify which types of credentials you want, which types of providers for federated, and you'll get undefined if there are no credentials stored. If there's more than one credential, and the account chooser pops up. If there's only one credential, you'll just get it directly. If you add unmediated true, this turns off the show the little chooser dialog. If the user has more than one credential offered in this case, if they have more than one credential stored, when you say unmediated, though, you're actually going to get undefined, so you kind of have to check to make sure that you know how many they have. So starting with Chrome 60, by the way, you should also add mediation silent. They're changing the terminology for reasons that are important, but I don't want to go into them too deeply here. So for compatibility, though, you should probably do both of these. Come on. Now, also remember, when a user signs in out of your website, you probably want to explicitly say, hey, next time, require the user mediation. Require the user to say, yes, I want to log in, because you don't want them to get signed back in automatically after they logged out. Now, once you receive a credential, like once you've gotten this object that says, hey, here's some credentials the user said they want to log in with, this is the interesting bit, and this is what's changed a bit recently, because a credential object hasn't exposed in the past the password to JavaScript. You have to use the fetch function in order to send the credential object to a server. Unfortunately, this didn't actually work very well in practice, because there's lots of systems out there, and a bunch of them did things like they wanted to send the password as part of a JSON object, or they wanted to send a hash value of the password to their server or something like that. So the Chrome security team and the working group working on this performed this security analysis, and they realized that actually concealing the passwords from JavaScript wasn't protecting them very much at all, wasn't preventing some attack vectors they thought that it would. So they decided to make a change, and now, starting in Chrome 60, so what's on Canary today, I think, you can actually access the raw passwords in JavaScript from Credential Manager. So this isn't really leaking anything that you couldn't have looked at before in the website, and this dramatically simplifies deploying with this API if you're one of those sites that wanted to put it into a JSON object or something. So obviously, feature detect this, check and see if you have credential.password. If you do, great, you can grab the password and use it. If you, on the other hand, if your server requires the password as part of a JSON object and you don't have credential password support, don't use Credential Manager. Fall back to your old way of doing things. And then, of course, you'll want to store credentials. This works just like it did before, effectively. You can explicitly submit a form to the Credential Manager API. You can say new password credential, hand it the DOM pointer to the form that has your login info filled out, and then call Navigator Credential Store. This is only if you don't want to rely on the heuristic. So you can do this in sign-up forms, that kind of stuff. Don't forget about password change forms, by the way. And I also mentioned Credential Manager supports federated accounts. This is pretty straightforward too. This stores, by the way, meta information about the account. It doesn't, like, this information gets synced across browsers, but it's not saving your OpenID tokens directly or that sort of thing. You're storing strings that represent the identity provider and probably an ID for the user, but not stuff that you could actually use to spoof the account elsewhere. And speaking of that, we actually made a change pretty recently in Chrome 57 where we mediate sharing credentials across subdomains. This is mostly the M-dot problem. So if you have a main site and then a mobile site and you want to share credentials across them, we can start doing that now. We couldn't before. And in fact, there's some work proposed for the future that will actually let you sign in using credentials to a totally different domain. Some large companies' SSO services use this, so it's kind of important. However, to do this, you have to set up this digital asset link thing, where basically each server points back to the other one and says, it's okay for this server to know about my credentials. And this lets you share across different servers. So that's the Credential Management API. We have lots more information online. There's a good article about it if you want to go read it. But even with that, paying for stuff is still kind of hard. And we still need pain-free checkout experiences. Because this is still how we pay for things online. And remember what I said about, hey, this is a horrible software keyboard? It's even worse when you're entering all of your credit card information, when you're entering numbers on a tiny little keyboard. And my personal favorite, if you're putting in a credit card field and you don't say, this is a number, so you still get the full QWERTY keyboard on there, I think you should hand in your web developer credentials and go find a different field. Like this is easy stuff to do, but checkout flows still look like this. We've had online transactions on the web for over 20 years now. Like someone said last night, the first transaction was in '94 online, which sounds about right. And you know, we know at the same time, long checkouts are one of the reasons people abandon carts. I mean, how many people here have abandoned a cart because the checkout was taking too long? There was too much to enter. Like, I do this all the time. It's probably good because, like Patrick was saying earlier, it's better for my wallet if I don't hit the button to buy stuff. And sometimes I tell myself I'll complete it later, either on mobile or I'll redo it on desktop or whatever, but I usually don't. And we have an opportunity to avoid this problem. And by the way, just in the US, mobile commerce sales will be over $150 billion this year. And you have to remember, mobile converts far worse than desktop. Mobile converts at about 1/3 the rate of desktop. So like people who go in, look at a good or service and then don't actually buy it, like that's 3 times higher on mobile than desktop. So there's a huge opportunity, and the web really does need a better solution for payments. Now the good news is we actually have one. PaymentRequest is an open standard. It's actually cross-browser, and I'll talk about that in a minute. But ready to be used today API for transacting on the web. We actually launched this in Chrome in September last year. And I want to be clear about what it isn't, too. So PaymentRequest is not a payment processor. It's not a service. This isn't replacing Stripe or Braintree or whoever. It's really just streamlining the management of payment types on the local device and enabling some third-party payment types as well. Because the existing world, like credit cards and CVC numbers and stuff like that, your addresses, those still have to work. They're still the way the world is going to continue to work. This isn't like, hey, we're going to sell you on the Google credit card, and this is the way to pay for everything. This is not what PaymentRequest does at all. So I want to briefly try to jump to a demo. And as an aside, I'm also showing you a second demo at the same time, which is this working on desktop, because usually we demo this stuff on mobile devices, but with Chrome 60, we actually have it supported on desktop. And let's see if I can get it to work. Okay, so Polycart is a shop that we built in Polymer. It's actually a Polymer demo too at the same time. But I'm going to go in, and if I can find my mouse cursor, I'm going to, I heard it was supposed to rain today, so I'll buy a jacket. Totally not the right size, but that's fine. And you'll notice when I hit Buy Now, this popped up immediately with a bunch of information that I have stored in the browser. I actually had to go into the browser this morning and figure out where it was pulling all this stuff from and change it so that I wasn't showing, say, my home address or my cell phone number on here, because, you all look kind of shifty. So don't, by the way, 555-1212, if you don't know this information number in any US area code, so don't bother. Anyhow, you notice it immediately pulled all of this information. This is the credit card information, and that is actually the last 4 digits of my corporate card, so good luck with that. It's pulling all this information from my actual credit card data that the browser has seen me enter before. In fact, if I go to this for the first time and I don't have anything in there, and it recognizes that I'm trying to enter a credit card, it will ask me if I want to scan a new one. And I can now hit pay and actually send payment to things. I'm not actually going to do that because I wonder if I'd have to expense that later. But the cool thing is, I didn't have to enter my credit card number. I could tell it if I wanted to. Like, let's go back and buy it again. I could tell it if I wanted to, you know what, I actually don't want to use this payment type, and I could flip to another payment type, have another card that was stored in there. I could choose to send it to one of my other addresses, that kind of thing, any of those things, and it's really just mediating all of that for me to make it easier. Let's go back to the slide deck here. Now, this is a demo site, but actually we have a bunch of merchants already shipping payment requests around the globe. I thought about it this morning, and I was going to demo this by sending my wife some flowers, since I have to be out of town. Unfortunately, 1-800-Flowers doesn't trigger properly on desktop. It's really picky about the request coming to their mobile site, so I couldn't. But there are a bunch of people who are successfully letting you buy things using the PaymentRequest API. So I want to briefly take a look at how this works under the hood so you understand how you can set up a payment request. And it'll also help figure out how this fits into the ecosystem. So first and foremost, you basically just say, how do I want to get paid? Like what sort of payment types I'm going to support. And there are 2 main types of supported methods in the PaymentRequest API. One of them is things that are baked into the standard, like basic card. And the way that Zach Cook characterized this at Google I/O is basically, if this is something that looks like a piece of plastic from someone's wallet, this is probably what you're going to do. And this is going to be the bulk of payments for a little bit here. Now, you can get more nuanced than that as well. You can say, I only support debit cards, or I only support credit cards, or I only support credit cards from Visa and MasterCard, or things like that too. I'm not going to go into that. There is more detail available, though. Now, the second type of payment method is what we call proprietary methods. And these are identified by a URL. Here, we tell the browser that we support Google Pay, which we announced at I/O this year. But this is the extension point. This is where you can plug in any other payment application you can use as well, and the browser will look to see if the user supports that. And then from all of these supported methods, they'll present to the user, okay, these are the ones you could use. Which one do you want to use? And this also, because we match against those, like we match what the user has versus what the vendor supports, we can have a really great default experience as well. The second thing that we want to pass in, and I'm going to get to what we pass it to in a second. The second thing we pass in are the details of the transaction. And Patrick actually touched on some of these earlier, but there's basically only two required things. You have to have a label, like this is the total purchase amount, and you have to have an amount of money, a currency code, and a value. There's an optional set of stuff you can put, like display items that lists everything on the receipt, sort of thing, the details. But these are informative details for the user, and these aren't validated or anything. We're not going to sum up stuff that's in here or that sort of thing at all. And you can also optionally pass in things that you'd like to get from the user, like, hey, I need a shipping address. You don't always need a shipping address, but if you do, you can say, I want that. You can ask for their email, their phone number, any detail you need to send them. And with this data, with request shipping true, it's actually going to say, hey, I need an address. And just like you saw in the Polycart demo, it's going to let me tap on an address to select. I have multiple addresses stored. It's going to let me tap one and say which one I want. I don't have to enter it by hand. So once I've got all these, some required, some optional things set up, that's when I construct my payment request. And I basically just create a new payment request object with the data that we've constructed, and then I show it. And show is the function that pops up the payment sheet that you saw earlier and shows it to the user. It's a promise. It's going to resolve when the user taps on stuff or says submit, that kind of thing. And then when that promise resolves, you just call complete on the request, and that tells the browser, go ahead and close the sheet down. And that resolves when the sheet is actually closed so that you can show your own UI to say, hey, the transaction's complete, it went through, or you can offer the user digital goods or that sort of thing. That's when you know it's done. Now, you can also, there's one other API method I want to mention specifically off payment request, which is can-make-payment. And this enables you to see if a user has that type of payment set up. So you can call can-make-payment and then see if they map to anything that you accept. Like if you only accept Google Pay, or you only accept credit cards, you can see if that works or not before showing the sheet. Now, payment request is actually coming to the entire Chrome family. It already works on Chrome for Android. It's working across Mac, Linux, and Windows. It even works on Chrome for iOS, which is the one that most people get surprised about. And we sync payment types across all those devices. Like the browser will help you deal with that everywhere. So like all of my credit card information is on my mobile device. I actually didn't enter it originally on my mobile device. I entered it on the desktop when I bought stuff. And Chrome's smart lock is remembering that. It also, however, works cross-browser. So the Edge team has already implemented payment request, as Patrick said. Samsung has launched. Firefox is still in development. And we're working closely with Apple in the working group. So we'll move right along. One of the coolest things, though, and I actually got into a side conversation about this earlier today, is this isn't, like improving the world for these is kind of pushing water uphill because someone said that people always hire the cheapest web developers to implement their e-commerce site. And I'm not going to go into just how incredibly bad an idea that sounds like to me, more than to say that's true. And in order to try to fix this, we've actually been working, and actually more than just the Chrome team, but everyone working on web payments has been working with a number of different channel partners, like the people who build e-commerce template sites, to implement this stuff and to bring the benefits to all merchants regardless of size. So you don't have to necessarily do this at every Leaf node site out there. People who use these kind of templates will actually get those benefits. But if you want to try this out, if you want to see if you can make this work, like Patrick said, you have this opportunity to just say, hey, does the browser support it? If so, let's do that. Otherwise, just go to the old checkout experience. There's actually even an easier way to get started, which is think about what percentage of your transactions that users complete on your site only have one item in the cart at checkout. Now, I know that data across the web that we've seen says that it's about 80%. Like 80% of transactions only have one thing in the cart. And this is kind of cool. Zach actually covered this in an earlier talk, and he said, this is kind of weird that we have this model of a cart, really, because we just mapped this model from a physical store where you go to the grocery store and you walk in and you get a cart or you grab one of the baskets, and then you walk around all the aisles adding stuff to your basket or your cart. And then you get to the front and you pay for everything all at once. But that's not really how people shop online. I mean, for the most part, they dive in, find a product or a service, pay for it, and walk away. Because they don't have to go into this store and wander around the aisles for a while and think, do I need this thing? Do I need this thing? So this flow is kind of weird of adding stuff into your cart, particularly when you're navigating on a tiny mobile screen. Now, there are some reasons why it's a good idea. If you're ordering a bunch of stuff from one place, of course, you'd want to save on shipping and have it go in one box or whatever. But a recommendation on how you can think about getting started is just if PaymentRequest is supported, conditionally show a Buy Now button. And have that Buy Now button fire up a payment request immediately. Because if they don't have it, if they don't support PaymentRequest, you just won't see this, right? You won't see a Buy Now button, you'll still see your same checkout experience. It'll work great. But if the user does have PaymentRequest set up, they can hit Buy Now, it'll pop up the sheet, they hit Submit, and you're done. And later you can decide if this conversion rate has helped you out enough to implement web payments everywhere. So I also want to mention briefly, I'm not going to dive into this in great detail. There is a lot of stuff online about it. But one of the things about the web, of course, is the web is worldwide, right? It's global. Payments are something that are very localized for the most part. There are some vendors that are pretty much international, but there's lots of ways that people want to pay for things that aren't in all markets, that aren't global. There's plenty of examples of this. Not everyone uses everyone's credit card, but if you go to China, for example, Alipay is already a really common way to pay for things, to buy goods and services. And, and the Web Payments API actually enables third-party payment types. Google Pay is actually one of those third-party payment types. And we're working with a bunch of other partners to bring their apps directly into Chrome. So Samsung Pay, Alipay, Square Cash. So on a mobile device, if you have these payment apps installed, we would know that from our browser implementation of PaymentRequest. And if the site said, hey, offer Alipay, if they have an Alipay account, we would know in the browser, oh yeah, you've got that app installed. I can fork that over to it. Now, on Android, we use the pay intent to do this. You have to have a payment app installed on your machine, installed on your mobile device. It identifies itself in their native app manifest, and then that tells us, what we need to know to accept it in the browser. Now, this seems kind of weird because I'm talking about a web API, and I'm talking about you need to have a native application needed here, installed here, and that's kind of goofy, and how does that work on desktop web? Well, the short answer is web app support is up next. We're trying to support this, support purely web-based payment applications. We've teamed up with PayPal to build out support, because obviously they're one of the key supporters of this, and have them be one of the first supported pure web-based applications out there. So you wouldn't have to install anything on your device, would work across all devices everywhere. And if you want to learn how to get started, we have a great integration guide. The Android third-party integration guide is how you can build a payment application. And we have a great code lab that we actually just released not that long ago. So with that, I really want to encourage you to think about how to continue building better and better relationships with your users using credential management, good login practice, of course, and PaymentRequest. And let's keep reducing friction in the web platform. With that, my Twitter handle is here. This deck is already online. I actually updated it before I walked on stage, so I know it's even up to date. And thank you very much. 1 minute. And I had 1 minute left on the clock, which is pretty awesome, because I wasn't sure exactly.
If you want, you can tell a joke before the Q&A starts.
No, that's okay.
Use your 1 minute.
Come up with one.
Okay. There were lots of questions on Twitter. You have a lot of reading to do. A lot of questions about payment providers. I'm not sure if you've heard about it, but here in the Netherlands, there is a payment provider called Ideal. A lot of websites use it. I'm from Belgium, and I know a lot of people there use it as well. So what does it take for this API to support their endpoint?
So for their endpoint, what they need is the part that I said at the end we're working on now. And when I say we, I don't mean we Chrome. I mean we, the web standards community in the payment working group.
So the server-side stuff, that's all part of the standard, right? It's about sending headers and...
Yeah, I mean, proprietary is kind of a weird thing to say here, because the goal with web payments from the beginning has explicitly been to not end up with a system where Chrome hard inserts some bit of magic code that knows how to pay for stuff with Android Pay or something like that. That is definitely an anti-goal. Like, we want, you know, if Google Pay is going to be awesome, we want it to work in Firefox and Edge too, right? And if it's not going to be awesome, us baking support into Chrome is not going to help that at all.
Right. Is anyone here present today? Does anyone work for Ideal? Because if not, you have to bring this up to your manager, because I think a lot of people are going to want this.
Hit me up on Twitter. I'm happy to find the right person for you to talk to get inserted there for any payment app.
Right. Another question is the payment or shipping data stored securely in the browser, and where? Because I remember a time passwords were stored in plain text. I'm not sure which browser this is, but...
Okay. Yes, they are stored securely, and they are stored in our internal browser syncing. Like, this is the Google Smart Lock in Chrome on Android is Smart Lock, and it's Chrome's browser sync is what we use across the board. It is secure. It's not stored in plain text anywhere.
Right. Of course, as soon as you get access to the device and it's unlocked, then you know, all bets are off.
Yeah.
Then nothing is secure anymore. Another question about the Credential Management API. You said a user who doesn't know their password is hard to phish, and I think everyone agrees with that. But aren't we moving the problem to the federated login servers then?
So keep in mind that the user not knowing their password being hard to phish isn't just about federated logins, right? It's actually more about letting the browser manage that with you. There's actually a different question that I'm sure someone is thinking, which is, wait a second, but that's a browser-specific cache. Like, Mozilla doesn't share a password cache, for example. So if I'm using Firefox and Chrome and I want both browsers to log into a site, yeah, you're going to need to know your password at some point, at the very least to copy it from one password cache to the other. But honestly, that's not most users. And you can still do that. Like, that's what I was saying of, we can't ship this feature until we figure out how to make sure that users actually can know their password, right? It's not, we don't ever want you to know your password. It's that you have to go figure out, you have to make it so that you don't really want to know it. Like,
Right.
I'll say my parents, I know somewhere in their house they have this book with all of their accounts listed in it.
Please no.
And it's not like out in plain sight or anything, but I know that they have it, and part of me cringes every time. But at the same time, I know that the way that I deal with this personally, because like I'm not going to write down my password, but I also have passwords to hundreds of different sites. And I do use multiple browsers, of course, because I test things across browsers. And like I store password hints to myself in a secure location. So I can go look them up on Google Drive or wherever I have them stored.
Two-factor passwords,
And
basically.
Basically,
Something like
yes.
that.
Yeah. Well, I mean, you need to know that bit of my brain that says, oh, that's probably what I meant when I put XXXX there based on context.
Yeah, I feel like I've asked this question already, but there were a lot of tweets about Apple Pay. Is it correct to assume that they would just have to implement the server-side bits that you mentioned before?
Yeah, there was some matchup concern with Apple, and to be clear, like Apple has been part of the Web Payments Working Group from the beginning. I'm pretty sure. I know that pretty sure they voted to have the working group. They shipped Apple Pay for the web slightly before PaymentRequest was really ready, but they apparently had some concerns about the way that some parts of it worked. And I know the group is trying to resolve those concerns so that they can make it work in this context too.
But they could theoretically be resolved in a backwards compatible way so that the code that we write would still work. Then.
Hopefully, yes.
Hopefully, okay.
Well, I mean, keep in mind, it's not going to be totally backwards compatible because you on your site are going to have to go in and say, hey, I support Apple Pay, and here's the bits that you need to pay me with Apple Pay.
Right.
So you would have to add something anyways. The hopefully doesn't require any changes part is you won't actually have to structurally change how your code fits together.
Yeah, that's the important part, I guess. Okay, there was one more question about cryptocurrency payments.
Oh, dear God.
Don't shoot the messenger.
Okay. Cryptocurrency payments.
Is it a matter of the payment provider supporting that kind of currency and it just doing the conversion?
Yes. So you could technically do this. You would need a payment application that supports cryptocurrency. Obviously, once the web-based payment applications are functional, you could supply this from any of the Bitcoin sites out there. You couldn't do it today without installing a payment application on a device. But certainly this sort of scenario is covered with payment requests. I won't say it's the #1 scenario, but I know that's been a point of discussion. So,
interesting. Okay, thank you very much for your amazing talk.
thank you.